Hi there, welcome to edupediaworld.com. You're watching the videos on circles. Now in this video we'll discuss the concept related to cyclic quadrilaterals. So what are cyclic quadrilaterals? Then we'll discuss some of the theorems related to cyclic quadrilateral. Then we'll discuss some of the examples which are very helpful and very important from the exam point of view. So you have to watch this video very carefully. Okay, now let's get started first with the first theorem. Now before discussing the theorem, let me just discuss or explain you what is cyclic quadrilateral. Suppose, let's say we have a circle like this, and let's say these are the 4 points on circle. So let's say if we join these 4 points like this, this and this, and let's say we name this points A, B, C, D, right? Now these points, when they are joined, make a cyclic quadrilateral. So we can say that ABCD is a cyclic quadrilateral. Right? Now, if this has to be cyclic quadrilateral, then what need to be done is that the opposite angles, the sum of opposite angles should be equals to 180 degree. Let's say we can say that angle A plus angle C should be equals to 180 degree, and angle B plus angle D should be equals to 180 degree. So this is a concept of cyclic quadrilateral, and the theorem says that the sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree. Means if in a quadrilateral, let's say if we discuss any other quadrilateral like this, P, let's say we have P, Q, R, S. Now what happens is if the sum of opposite pair of angles is 180 degree, then it's a cyclic quadrilateral. Or if angle S plus angle Q is 180 degree and angle P plus angle R is 180 degree, then it's a cyclic quadrilateral. So this is all about the theorem number 1. Now let's discuss the next theorem, theorem number 2. Now if the sum of pair of opposite angles of a quadrilateral is 180 degree, then the quadrilateral is a cyclic. Means it is actually a converse of the theorem which we have discussed in the previous section. Means let's say if we have a quadrilateral like this, let's say P, Q, R, S, and the sum of pair of opposite angles is 180 degree. Let's say angle S plus angle Q is 180 degree and angle P plus angle R is 180 degree, then we can say that PQ RS is a cyclic quadrilateral. So this is all about the concept of cyclic quadrilateral, which is very important when you are solving the questions. Okay, now let's discuss some of the examples related to the theorems so far we have discussed in the videos of circles and the concept related to the cyclic quadrilateral. So let's get started with the first example. Example number 1. Now it's a very good example. You have to watch this very carefully now. Now example says that AB is a diameter of a circle and CD is a chord equal to the radius of a circle, right? And AC and BD when extended meet at point E. So this is a point E. We need to prove that angle AEB is 60 degree. Means we need to prove that this angle is 60 degree, right? So first of all we need to write given. It's given that CD is a chord which is equals to radius of circle, right? Now first then we need to do some construction over here. Construction is we need to join point CO and OD, and let's say we make CO and OD, and which forms a triangle. Now if you see properly, CD is equals to radius, CO is radius, and OD is radius. So we can say that triangle COD is an equilateral triangle. We can say that it's an equilateral triangle, So why it's an equilateral triangle? Because all the sides are equal. Why? Because all the sides are radius. Since it's given CD is equals to radius, CO is radius, OD is radius, so it's an equilateral triangle. Right. Now let's discuss the proof now. So let's see. Now if triangle COD is an equilateral triangle, then we can say that angle COD is 60 degree. Why? Because in equilateral triangles all angles are equal, so each and every angle of an equilateral triangle is 60 degree, so we can say that angle COD is 60 degree. Now for like this, then we can say that angle CBD will be half of angle COD. Why? Because if CD is a chord, then we can say that if CD is a chord, then we can say that angle in same segment is half the angle at center, right? So we can see clearly that CD is a chord, then CBD is an angle made on the circle, and COD is angle at the center, so angle CBD will be half the angle COD, so we can say that angle CBD will be half of angle COD, which is 60 degree, so angle CBD is 30 degree, right? So we have this angle as 30 degree. Now similarly we can say that angles ACB is 90 degree. So why it's 90 degree? Because AB is a diameter, AB is a diameter, and it subtends 90 degree angle at the center, right? Diameter, and subtends 90 degree angle at any point or at circle, we can say that. So that's why angle ACB, so this angle is 90 degree, right? Now if you see properly, ACE is a straight line, right? So we can say that angle ACB plus angle ECB is 180 degree, because angles on a straight line is 180 degree. So we can say that angle ECB will be equals to 180 minus angle ACB. So angle ECB will be equals to 180 minus 90. So angle ECB will be equals to 90 degree. So this angle, let's say this angle is 90 degree now. Now if you consider triangle ECB, then in this triangle we can say that angle ECB plus angle, let's say this angle, it is angle EBC plus angle CEB will be equals to 180 degree. Angle sum property, we can say that angle sum property, right? Now angle ECB is 90 degree, so let's write 90 over here, plus EBC, so this angle, we have proved this angle as 30 degree, right? Angle CBD, it's also an angle CBD, so we can write 30 over here, plus angle CEB equals to 180 degree. So from this we can say that angle CEB will be equals to 180 minus 120, so which is equals to 60 degree. So we can say that this angle is 60 degree, or angle AEB is 60 degree. So this is how we can prove these type of questions. So let's move on to the next question now, or example number 2. Now example number 2 says that ABCD is a cyclic quadrilateral. So ABCD is a cyclic quadrilateral in which AC and BD are its diagonals. If angle DBC means DBC, so this angle is 55 degree, and angle BAC, this angle is 45 degree, so we need to find angle BCD, right? So we need to find this angle. So let's see how we can solve these type of examples. So first of all, we need to write given. It's given that ABCD is a cyclic quadrilateral, right? And it's given that angle DBC is 55 degree, angle BAC is 45 degree, right? So we need to find angle BCD. So let's see how we can solve this. So let's discuss the proof now. If you consider CD as chord or segment, then we can say that angle DBC equals to angle DAC. Why? If you can see properly, if this is a chord CD, so this chord subtends an angle DBC over here, and if you see same chord subtend this angle DAC, so we can say that they are equal. Why? Because they are angles in same segment, right? So we can say that angle DAC is also equals to 55 degree now. So this is 55. So we can say that this complete angle, if you can see properly, let's say we can say angle DAB will be equals to angle DAC plus angle BAC, right? So it will be 45 plus 55, so it is 100 now. Now since it's a cyclic quadrilateral, so sum of opposite angles is 180 degree. So we can say that angle A plus angle C equals to 180 degree. Why? Because ABCD is a cyclic quadrilateral, right? Then so we can say that angle A, which is also angle DAB, so we can say that 100 plus angle C equals to 180 degree. So angle C is 180 minus 100, so which is 80 degree. So we can say that angle BCD is 80 degrees. So this is how we can use the concept of cyclic quadrilateral to solve various problems related to circles. So let's discuss the next example. Example number 3. Now, example number 3 says that two circles intersect at point A and B, and AD and AC are the diameters to the circles, right? So we need to prove that B lies on the line segment DC. So we need to prove that DBC is a straight line, right? So let's first we need to write given. It's given that AD and AC are diameters, and right, so what we need to prove, we need to prove that DBC is a straight line, or we need to prove that angle DBC is 180 degree, right? So let's see how we can prove this. So let's discuss the proof now. Now since it's given that AD is a diameter, so we can say that angle ABD is 90 degree. Why? Because we can say that angle in a semicircle, right? So if AD is a diameter, then this angle is 90 degree, so angle in a semicircle. Similarly, angle ABC is also 90 degree. Why? Because it's again angle in a semicircle, right? Now if we add these two, let's say this is first and let's say this is second, so let's say angle ABD plus angle ABC equals to 90 plus 90. Now angle ABD plus angle ABC means this angle plus this angle, so it will be angle DBC, which is equals to 180 degree. So we can say that now DBC is a straight line and B similarly we can say that B lies on the line segment DC. So this is how we can use the concept of angle in a semicircle to solve various examples. Now let's discuss the last example of this video. Now the example, it's very good example, so you have to watch this example very carefully again. Now we need to prove that the quadrilateral formed if possible by the internal angle bisector of any quadrilateral is a cyclic. So we need to prove that this part, this, let's say we need to prove that FGHE is a cyclic quadrilateral. Cyclic quadrilateral. So let's say how we can prove this. Now it's given that this angle equals to this angle and this angle equals to this angle and this angle equals to this angle and this angle equals to this angle. Why? Because they are all internal bisector, right? Now we can say that, so let's discuss the proof straightly, directly. Can say that angle FEH, right, equals to angle AEB. If you see properly, this angle and this angle, they are vertically opposite angles. Why they are equal? Because they are vertically opposite angles, right? Now angle AEB plus this angle equals to 180 degree because they are angle sum property. So let's say we can write angle EAB plus angle EBA equals to 180 degree. Why? Because again we can say that angle sum property, right? So now we can write angle AEB plus, now angle EAB, this angle can be written as half of angle A because they are internal bisector, so we can write this as half of angle A. Similarly angle EBA can be written as half of angle B, which is equals to 180 degree. So we can write angle AEB equals to 180 minus half of angle A minus half of angle B. So let it be first. Since angle FEH is equals to angle AEB, so we can write angle FEH equals to 180 minus half of angle A minus half of angle B. So let it be first, right? Now similarly we can say that angle FGH equals to angle DGC or angle DGC. Again they are vertically opposite angles, right? So we can say that angle DGC plus angle GDC plus angle GCD equals to 180 degree. Again it's an angle sum property, right? So now angle GDC can be written as half of angle D because they are internal bisector, so we can write angle DGC plus half of angle D. Similarly for this angle it can be written as half of angle C, which is equals to 180 degree. So angle DGC can be written as 180 minus half of angle D minus half of angle C, right? Now angle DGC is equals to angle FGH, so we can write angle FGH equals to 180 minus half of angle D minus half of angle C. So let it be equation 2. Now you can say that adding 1 and 2, what we get, angle FEH plus angle FGH equals to 180 minus half of angle A minus half of angle B plus 180 minus half of angle D minus half of angle C. Now 180 plus 180 is 360 minus, if we take half common out, so it will be angle A plus angle B plus angle C plus angle D, right? Now angle A plus angle B plus angle C plus angle D is 360 because sum of angles of our quadrilateral is 360 degree. So we can write this as 360 minus half of 360. So this and this get cancelled. So it will come out to be 360 minus 180. So which is equals to 180. Now angle FEH and angle FGH, they are the opposite pair of angles of a quadrilateral and their sum is 180. So we can say that FGHE is a cyclic quadrilateral. So this is how we can use the concept of cyclic quadrilaterals to solve various questions related to the circles. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day ahead.